whether we have hit or not, the Boolean that says whether we've hit. And then the second bit is inside the if statement.
The future of your business is here. With Wix, you get advanced AI.
Statement, which we can probably leave as the job of grabbing, because that's actually to do with grabbing, right? We have to wake the rigid body, we have to grab a component. And that makes sense to be in a function called grab. But this other stuff is a little bit more tangential. It's more of a utility that we need to pull in. So I'd like to challenge you to create that utility. Get grabbable in reach. That's what I think it should be called. I think that describes what that lump of code does. So extract all of that sweep code into a new private function. Have a think about what its parameters and its return value should be. Remember, you've got two outputs. So you've got has hit and hit result. So you need to think about trying to use an out parameter to make this work. Now, if you want a little bit of a hint, I'm going to show you what I'm going to put in the header file in just a second. If you don't, you can go and pause the video right now. .h, and underneath where we've got get physics handle, we are going to have a Boolean return type to tell us whether something has been, we can get something grabbable. There's get grabbable in reach. Then we need to give it a parameter, which is going to be an out parameter. So it's going to be a non-constant reference to the f hit result. Put a reference ampersand, and then we'll call that the out hit result, like so. And then I think this isn't going to change anything in our function, so we can make it const as well. So little bonus points if you had already thought of that. So go ahead, pause the video, and try and fill out that function in the C++ file.
probably know Vistaprint for business cards, but did you know we print everything you need to brand your business? We print banners and signs that help you stand out, and must-have merch like tote bags, t-shirts, and hoodies. If you need it, we print it. Print it all with 20% off for new customers with code NEW20 at Vistaprint.ca.
Okay, welcome back. So I'm going to copy it, go over to the C++. I'm going to put it underneath our getPhysics handle component to match the order we've got over in the header file. I'm going to add the U grabber in front. I'm going to indent it correctly. I'm going to add, instead of a semicolon, the braces. And then I'm going to move the code that we've got over in grab. So starting at line 53 for me down to 65. I'm going to cut all of that out. We'll replace it with something in just a second. I'm going to paste it into get grabbable in reach. And we've got this hit result that we've created. What we can do is we can set that out hit result equal to our hit result that we've got here. We might only want to do that if we've hit, so we can put that if statement has hit like so, and wrap this assignment, the out hit, to the hit result inside the if statement, and then we can go ahead and at the end of the function just return has hit like so. Now there is an optimization or an improvement that can be made here because we are passing by reference into the sweep channel and into grabbable in reach. We don't actually need to create a new hit result in here and then copy it into the hit result. That's just wasting memory. What we can do is we can remove the hit result that we're creating inside get grabbable in reach, and instead we can just use the reference that we've had passed in to pass directly into the sweep single by channel. So it's actually passing this reference two functions down into the sweep single by channel where it will get populated. And that removes the need for the if statement, making this function a little bit quicker and easier to read. And in fact, I don't think we even need a variable to store has hit. We can just go ahead and return. It's going to be much cleaner to return the get world sweep channel results. So we're just kind of passing the results from that through back up into get grabbable in reach, or whoever is calling it. So talking of whoever is calling it, we now need to go up into our grab. We need to create our f hit result somewhere. We have to create it here. So hit result, this is the one we're going to populate. We're going to then create a Boolean variable, which is going to be has hit. We're going to set that equal to get grabbable in reach, and we're going to pass in the hit result by reference that we want populated, and then if we have hit, we're going to go ahead and execute the grabbing code. Fantastic stuff. We have moved something into a function to make this grab function fit on a single screen, and we've again made use of out parameters, this time creating a function for ourselves that use them in earnest. I'll see you in the next video. Hello and welcome. In this lecture we're going to be creating a new component in C++, this trigger box, which will report to us when we step inside the alcove or we place any object in the alcove. You can see we're getting a little blueprint message up in the top left-hand corner, and to do that we're going to have to understand how overlaps and blocking and different collision responses behave in Unreal. Let's dive in and find out. Now, we've already become familiar with how trace channels work. We know that you can have trace responses on the different objects in our scene, such as this shrub here. You can see that it has an ignore response to weapon traces, but it does block visibility traces. Then there's this bulletproof glass example. It blocks weapons but allows visibility through, and a brick wall which blocks both. So you can see how this system works with trace channels. Now, what happens if we're trying to decide which objects can overlap with each other, which ones pass through, which ones block each other? That can get a little bit more complicated. We saw this already when we tried to get the gargoyle to overlap with our pawn. Now, this is how it works. Essentially, we use these object types. Each object can belong to, can be a particular object type. And this is different to the kind of type system in C++. These are collision types. So you might have object A and object B, and in their settings, if we go and have a look at the settings on our gargoyle, for example, you can see that they have their own object type. This one is a world static object. But then further down, they have their responses to other types of objects as well. So you can see that this object will block other world statics, it will block other world dynamics, it will overlap the pawn types, it will block physics bodies, and pretty much block every other type. And obviously, the pawn itself, if we go and find our BP player and look in its capsule component, look at the details and scroll on down to where it's got a collision preset. If we can expand out the pawn collision preset, we can't edit it, but we can see what it's doing. And you can see that it has its own response to world static. So its response to the world static would be to block it. So we've actually got two different options here. The pawn is saying, I block world statics, but the gargoyle is saying, I overlap pawns. So what should happen? Well, this is where this table comes in, and I've got a link to this blog post if you want to read it in full in the lecture resources. So you can see that it takes the least blocking interaction between the two. So if object A was the pawn and it's saying, hey, I should block that gargoyle, but the gargoyle's object B and it's saying, hey, I should overlap that pawn. So it's going to take the least blocking of those two and it's going to overlap. So it does mean that if you want two things to block each other, they both need to agree that that's what they want to do. So let's look at another example here. We've got the player, which is of object type pawn, and its object response to other pawns is to block them, and the world static object is to block them. The brick wall is a world static object. It can block pawns and block world static. So these two would agree with each other. Now the shrub is also world static, but it overlaps pawns. This is very much like our gargoyle, but it blocks world statics. So if you go down and have a look at what would happen, is the pawn would try and travel through the bush, and it could, because it takes the least blocking option, which is overlap, and it generates an overlap event, which we can hook into in code or blueprint, whereas it won't be able to pass through the brick wall, and it generates a hit event, again, something that we can hook onto in Blueprint or C++. So why do I go into all of this depth? Because what I want to do is put an object that is basically invisible inside this wall that allows us to put the gargoyle in here, and we get an event when that happens. So the gargoyle will prop up an event and say, hey, I've got something overlapping with me. So why is all of this important? Because I want to put an object that's invisible but will overlap with the gargoyle and let us know about that fact. We can then query it from C++, or we can get events in Blueprint either way. And the way we're going to do this is, first of all, create a blueprint from this dungeon wall. So I'm going to click the blueprint button in the details pane, create a new subclass, and I'm going to name it BP underscore secret wall. And we're going to hit select to create it and dock it to our main window. And it's got a mover on it. What I also want to add in here is essentially a component which is called a query it from C++ button in the details pane, create a new subclass, and I'm going to name it BP underscore secret wall. And we're going to hit select to create it and dock it to our main window. And it's got a mover on it. What I also want to add in here is essentially a component which is called a box collision. So if we click on a box collision, you can see it's completely invisible. It just gives you some box extents which we can change. We can make them larger so that anywhere we place the gargoyle in this box, it's going to accept it. And we can see that it has got collision options down here. We've got an overlap all dynamic as the default, as the default preset, but if we hit custom, you can see we can change the object types, and we can change how it responds to different things in here. And I think most importantly, as you can see, it's set up to overlap with most object types, which means that even if they're not set to overlap with world dynamic, it's going to overlap. It's not going to block anything. It's going to let us position the gargoyle in here. So I'm going to go and delete that component from the scene, because what I want to do is create a new component in C++ based off of that box collision. Now I just want to show you that with this box, if we set it back to the default preset it was on, which was overlap all dynamic, I believe, and we check, or as is already checked actually, generate overlap events is already checked, then we can go over into our event graph and we can right click in here and look for overlap, and right at the top you can see an add on component begin overlap for the box. So if we click that, and actually let's rename the box component to trigger area, like so. And basically if we overlap with the trigger area, we're going to get a list of properties of the thing that's overlapping with us. So we could take the actor that's overlapping, we could get its name. So get display name is the name of the node, And then we could take that and print the results string and hook that up to the execution pin. And we can go ahead and hit play. And if we walk up to the area, you can see that it's saying the BP player is the thing overlapping it. Now, I can't see that area because it's so dark. So I'm just going to go to the secret wall again, BP, and I'm going to add in a spotlight component, which I'm going to place in this little alcove, rotating it to face down and illuminating the space where we want the object. Now in the scene we can see it very clearly, so let's go ahead and hit play, and we can walk up to that alcove. If we overlap it, it says there's the BP player overlapping, and we can go and grab our gargoyle from this cell using our newly minted grabber, and we can take that gargoyle and place it in this area. However, it doesn't seem to be generating any overlap events. And that's because just like there's two parties to the collision, there's also two parties to generating overlap events. So just because we have it enabled on that box component doesn't mean that the gargoyle moving into it is actually going to alert us to any overlap events. So what we have to do is we have to go to the gargoyle and check its generate overlap events as well. So then the overlap events should happen. Let's go and pick up the gargoyle, take him over to the alcove and stick him in. And now we are getting an event coming up when that happens. The gargoyle statue move enabled on that box component. doesn't mean that the gargoyle moving into it is actually going to alert us to any overlap events. So what we have to do is we have to go to the gargoyle and check its generate overlap events as well. So then the overlap events should happen. Let's go and pick up the gargoyle, take him over to the alcove and stick him in. And now we are getting an event coming up when that happens. The gargoyle statue is indeed being registered. Now, I don't want to be using blueprint events in this particular case. So what I want to do is take our trigger area component and actually turn that into a C++ component that can evaluate whether it's got the gargoyle statue it wants or not already in it. The way we're going to do this is we're going to go to the add components, create a new C++ component, and as the parent class, instead of choosing act component or scene component, we're going to go to all classes and we're going to search for the box component instead. And you can see there's shape components, box components is the one we want, and we can go ahead and hit next. So I'd like to challenge you to create this component now that I've shown you how to set the parent class. So you're going to name it trigger components, and you're going to have to copy some things from the other components we've created because it's not set up in the same way, seeing as we're deriving from a different parent. You're going to have to copy the uClass line. That whole line is basically empty on the trigger component as you will create it. So copy that from either your grabber or your mover, and otherwise you won't be able to add your components into your blueprints. So then you should use this new trigger components to replace our current box components and print something from begin play. Again, the begin play won't be set up automatically for you, so you're going to have to copy from the header file and C++ file of our other components in order to set it up. Pause the video and have a go. Okay, welcome back. So I'm going to call it the trigger component, all one word. Got nothing inside the parentheses. And if we go and have a look at our editor and go to the BP secret wall, try to add this component, search for trigger, you can see nothing blueprint spawnable component. So crucially, we need to copy. It's got begin play. It's within just underneath the generated body. Then we can go into our grab a CPP and see how begin play was defined in here. You can see that it has this called the super begin play. That is actually important. So we're going to copy that, go over to trigger component CPP. Trigger component begin play, and then in here we can put in our new log, and we're just going to write a simple message such as trigger component alive. We'll go ahead and compile. It's going to take a little while, seeing as we've made some fairly significant changes to our header file. And once that's done, we can go into our BP secret wall, go to add and search for trigger. And here you can see we've got the trigger component. We can now add that in. We can remove our trigger area that we've set up previously. Just go ahead and delete that and check. Yeah, we want to delete it. It's going to basically invalidate this event we created. And we can check that the collisions are set up as we want on the trigger. We're going to have a look. Yeah, it's set to overlap all dynamic and to generate overlap events. And finally, what we need to replace is this event here. We're going to select that trigger, right click, and go to unfurl the add event. For trigger, collision, and add on component begin. That's what we were using before. Look up the active pin. Look up the execution 2. Head over to the dungeon level. Go and pick up the gargoyle. Try and stick it in the alcove. And we notice that's not working. So now we've got that trigger set up. Let's go to the viewport, and you can see that actually the trigger hasn't been made big enough. We haven't positioned it. keys so that we catch whatever we put inside this alcove area. Doesn't matter if it is a little bit bigger and gives us a safety margin, then we can go into the dungeon, hit play, and then step into the alcove. And sure enough, it detects that the BP player has walked into that alcove. Great stuff. In this lecture, we've learnt all about object types and object type responses, and we've used that to set up this trigger component. I'll see you in the next lecture. Hello and welcome. In this lecture we're going to be looking at a special function called the constructor that allows us to give default values to properties in our class, and we'll see when it's called in the editor. Let's dive in and find out. Now with this trigger component, I would like to add a tick component function in here so that we could check which components, which other actors are currently overlapping this trigger component, and we could activate if it is the right kind of actor. The problem is, well, we'll see what the problem is. Let's try and implement a tick function. If we go over to the grabber.h to see what the declaration of a tick component function should look like, it needs to be in the public section. It's a virtual void tick component delta time. There's lots of parameters, so let's just copy it, go over to the tick component header, add it in underneath our begin play, and then we're going to copy that definition, take it over into our trigger component CPP. And one thing that we'll notice is there's a couple of keywords here that we can remove. We can remove the virtual keyword. That's generally a rule that we can follow. We can also remove the override keyword. These are things that don't need to be in the C++ file. We need to add the class name, so uTriggerComponent : : then we replace our semicolon with some braces, and we need to make the call to the super tick component. So because that's quite a long call, I'm going to copy it from our grabber CPP and paste it in to this one. Now what this is doing is it's essentially calling the parent's tick component function. So the parent in this case being our box component. So it's important to call that in case there is any functionality there that needs to be used and enabled for this component to work. If we don't do that, we're essentially bypassing any of that functionality and things can break. So very important to always remember to call to super when we are implementing begin play and tick component. Now let's copy our log message from begin play and put it in tick component. And instead of saying tick component live, I'm going to say tick component is ticking in here, and we're going to go ahead and compile and see whether that tick is actually working. Once the compiler has finished, let's go ahead and hit play, open up our output log, and well, nothing seems to be happening. Now the reason for this is that optimization wise, they automatically in Unreal, most components have their tick switched off. So actors usually have it switched on by default, but components usually have it switched off. So in fact, if we look at some of the other components that we've got, such as our mover that we know ticking does work for, you can see that at the top of the file, there is this uMover function, and it's got this primary component tick dot b can ever tick equals true. If you don't set this property on the class, so this is a property of the class. There's a property of the class called primary component tick, and it is a struct that has a b can ever tick property within it. So what we're doing here is we are setting this default value on the mover class when we construct it. That's what this function is. It's called a constructor, and it is a function that gets called whenever we create a new mover component to automatically set default values. We can set some default values over in the header file like we've done with should move, move time, but an alternative to doing it over in the header file is that we can actually set these properties in the constructor. Now I'd like you to notice the syntax here. If we go over into the mover header file, you can see that a constructor is named exactly the same as the class. So the uMover is the class name for our mover component, and its constructor is also called uMover. Notice it has no return type either. It doesn't make sense to return anything because we are constructing a new object. We are just making this class happen. So all we need is access to the properties of this class. And also notice that it is set to public, so it's in the public section of our class definition. So I'd like to challenge you to enable ticking for yourself. So you can, again, in those other components, pause the video and it's not uTrigger, it is uTrigger component in full, and we can make the implementation here. Again, we don't need a return type, so it's just put that there. Let's type that out. Live coding, I'm going to click. It's working now. What if I go ahead time, and then with the thing showing it's actually, you can see that it is constructing way ahead when it's just creating the world. It starts constructing very early before, obviously, begin play, because we need to get the whole world ready before we start playing. So it happens when we hit play, but in actual fact it also happens in the editor. So if I select some actor here and then add a component to it and add our trigger, then have a look at my output log, then you can see the constructing message was actually printed. So we need to be careful what we do in our constructors, because they actually get called, the C++ code gets called just when we're editing, not even playing our game. These objects are being created and therefore set up, and therefore need to call their constructor. I'm going to go ahead and delete the trigger again and clear up a little bit by removing our constructing log message and our begin play log message as well. Great stuff. So in this lecture we've seen how we can set up our own components so that they're almost identical to the ones created in the templates for scene components and act components. We've seen how to use a constructor to give default values to properties in our class. I'll see you in the next lecture. Hello and welcome. In this lecture we are going to be accessing the overlapping actors in something called an array, so that we can be printing out the actors that we see inside this volume entirely from C++. Let's dive in and see how it's done. So as in previous analogies, let's box in 5 variables, but what if we had something that is unpredictably many, such as the number of actors we have in our level, or the actors that are overlapping with a particular... trigger volume. In this case, we need to use a new data type called a T-array in Unreal, and basically a T-array of a certain type. Here again, we're seeing these angle brackets that are, as we said previously, compile time parameters, and this time we're taking in again a type that is telling us what type we can store in our array. An array is like a variable, except that it has multiple boxes, and the number of boxes that we have can be different when we're playing our game. It can change, we can add more or less as we go through the game. As things start to overlap, we'd add more boxes. As things leave the overlapping zone, we'd take them away. And as I said, this is a parameter within these angle brackets, and so we could have a T-array of ints, for example, which would store different integers in those boxes. We could have a T-array of actor pointers, and this would actually store the pointers in the boxes, which would point to actors out in the world. And as you can see, they could even overlap, so that some of these pointers point to the same actors. Now, in practice, that wouldn't be very useful, but it's certainly possible. So I want to revisit the documentation of the uPrimitive component, because what I'm looking for here is a function called getOverlapping actors. And if you have a look at the getOverlapping actors function, there's a couple of versions of it, but the one that's most interesting to me is the second one. It doesn't have a return value, it's a void return value, but you can see that the first parameter here is a T-array of actor pointers with an ampersand at the end, meaning that this whole thing is a reference to a T-array. Now notice it's not a const reference, so we can assume that this parameter is actually an out parameter. It gives us the result of the thing. So our second argument here, but we don't need to worry about that because it's actually got a default value if we use it. So let's go ahead and try and get hold of and populate a T-array of actor pointers. We're going to go into the trigger component CPP, we're going to go down to the tick component, and in here we're going to create an empty T-array that we can populate using this function. So the syntax is T-array, open angle brackets, a actor star, to say that we're having a T-array of actor pointers, close the angle brackets, and then we can give this variable name as actors. Then we would call to get overlapping actors, and we would pass in the actors array. Now, I don't know why they don't just pass this out as a return value, but there you go. It gives us an opportunity to use those out parameters a little bit more. Now, that's all well and good. We've got some actors in an array. There's a variable length of them. There might be quite a few. There might be 0. What do we do with arrays like this? Well, we can query how many items are in the array. You can use array.num. parentheses, and that can return an integer telling you how many items are in the array. So in this particular array, we can say that there are 5. And then we can access the items inside that array by using these square brackets. And then the number that you pass into the square brackets tells you which item to get. And it's a usual convention in a lot of programming languages that we start counting from 0 in arrays. So the 0th element of an array is the first one, the 1 element of an array is the second, etc. And so you end up with the last element always being 1 less than the number of elements in the array. So how can we use this knowledge? Well, for example, we could only print the overlapping actors if there is more than one of them. So how would we do this? We would put an if statement saying that if the actors.num parentheses is greater than 0, then we can do something in here, such as get access to our actors 0 element, because we know that if it's greater than 0, then there must be at least one element in there, so the 0th element of this array must have something in. We couldn't guarantee that the first element, the 1 element of the array, has got anything in, or the 2 element has anything in. We would have to check whether we have enough items in the array in order to do that, but we definitely know that there is the first one here. So I'd like to challenge you to print the first overlapping actor from that array. Use the array to get the pointer using those square brackets. Then you're going to use that pointer to call get actor name or label, and then you're going to print that out. Pause the video and have a go. Okay, welcome back. So we have got hold of the pointer here using this square brackets, and I'm then going to get hold of the name straight away by using the arrow operator and calling get actor name or label, and I'm going to put that in an F string variable called actor name. Then we're going to do a ulog, which we're going to call the overlapping colon and then %s. And then the second argument here should be asterisk actor name. Then we can recompile, hop into our output log, dock it in the layout. Then we're going to open up the BP secret wall, because I don't want to be printing this string that confuses things in Blueprint. We're doing this now from C++. So let's go over into the dungeon level, hit play. And obviously nothing's overlapping that actor right now. So what happens if we go and step inside? You can see that it instantly starts printing that we're overlapping the BP player. Fantastic stuff. What if we were to go and get the gargoyle instead? Take it over to the alcove, stick it in, and there you go. It says it's overlapping the gargoyle statue. Great stuff. So to use a T. In the next lecture, we're going to be looking at Hello and welcome. In this lecture, we're going to be learning how we can execute a piece of code variable numbers of times so that we can print out every object that overlaps inside this area, this trigger component. So you can see here that when I'm standing inside and there's a gargoyle too, it's printing out both the gargoyle's name and the player blueprint's name. Let's dive in and see how this is done. Now the issue with our code here is that our actors array may have far more than just one actor in it. And if we wanted to display all of the actors overlapping, or we want to do something with all of those actors, we need to be able to run through the code. It would be highly inefficient to write an if statement for the case where we've got 2 or 3 or 4 or 5, etc. And it certainly would never catch every case because we've got a limited amount of lines in our file. So the way we deal with this, when we want to repeat a piece of code multiple times, but a number of times that we don't actually know when we're compiling the code, we need to replace our if statement. Our if statement essentially says, should I execute this code or not, with something that says, should I execute this code or should I execute it many times, 2 times, 3 times, 4 times, etc. The way we do this is with something called a while statement. Now, it's built very much like an if statement. So the while, you then put some sort of Boolean value inside the parentheses, and then we have some curly braces, and inside the curly braces a block of code that will keep getting executed again and again until the condition in our while statement becomes false. That's why it's called while. So while this thing is true, execute this code. So it's a bit like an if statement in that sometimes it might not execute the code at all, but unlike an if statement that can only execute a piece of code once, the while statement could basically keep on executing it forever if this Boolean never becomes false. So why is this useful? Well, we could create an int 32 and call it index and start it off at 0. And then every time we go through the body of this while loop, we increase the value stored in that index. So we could say index equals index plus 1. Now, in C++, there is a shorthand to doing this. Instead of having to do index plus 1 like this, you do plus plus index, and that just adds 1 to whatever is stored in the index variable. Okay, so we start off at 0. Every time we go around, we increase the index. And what we can do is we can make it so that we only go around this while loop while our index is within the bounds of our array. So we can say that the index must be less than the actors.num. So that is the size of the array. Remember that when we've got 5 items in an array, the last item in the array is index 4. And so we can see that this will be true when the index is valid, when index 4 is less than 5. But as soon as our index goes past the end of the array, when it gets to index 5, then the actor number is going to be no longer is 5 is no longer less than 5, so the while loop will stop executing and continue with the rest of the function. So what that means is we could now take the code that we had above and rewrite it. Let's take it, copy it, cut it out, and stick it in here in our while loop, but before we increase the index, most importantly, because what we're going to do is replace this 0, where we were getting actor 0, we're going to replace it with actor index. So let's follow this through. How would this work? Let's remove our if statement because that's confusing matters a little bit. So we start off, the value in the variable index is going to be 0. Now imagine we have 2 actors to keep things simple. Is 0 less than 2? Yes, it is. So we go in and we get actor 0, we get its name and we log it out, and then we increase the value in index by 1. So it goes from being 0 to being 1. Now we go back to evaluate the while loop condition and we say, is 1 less than 2? Yes, it is. We can then go in and get actor 1, and then we're going to get its name and print its name. while loop saying, is 2 less than 2? Well, that answer is no. So we skip over the body of the while loop and we go on and execute the rest of the code. So that's basically what we want to achieve. We want to print out the name of each actor in the array, and that's what this piece to the box, to the bounds, its print to loop is so common that this is a general structure. It's got something called a size t here. We can just replace. There are 3 statements inside the parentheses of the fin, which is equivalent to what we put inside. See that this is increasing the value of your while loop to change the index from that name index to I. We typically use the abbreviation. Don't want the index array with the for loop. That's another advantage, by the way, of the for loop syntax, is that the I variable is only available within the for loop, whereas when we declared it here in the while loop, it's available outside, which kind of pollutes the indexes we can use later on. Hello and welcome. In this lecture we're going to be looking at an even cleaner syntax for for loops, which we use specifically when dealing with arrays or collection types. Let's dive in and see how it looks. So this pattern of iterating over all the actors in an array is so common that we actually have our own type of for loop specifically designed for this purpose in C++. So the basic format of this for loop, it's called a range-based for loop, works like this. So we start with the same keyword, we have some opening parentheses, but then instead of having these 3 statements, we do the following. We create a variable to store the pointer or the thing within the array that we are looping over. So in our case, it would be an actor pointer, which we can call the actor. Then you put a colon, and then you put the array. So that would be actors. So the way this reads is essentially for actor star actor in actors. And what that's going to do is it's going to loop over every actor star that is in the T array. Now this doesn't only work with T arrays, it works with all sorts of different collections So this is very useful because now we've got in each iteration of our for loop a pointer to a different actor from the array, and it's just a lot cleaner and simpler and easier to read than the for loop above. So I'm not going to give you a challenge slide here. I just want you to convert from using this 3-statement for loop to using the range-based for loop instead and test out your findings. Pause the video and have a go. What am I going to need to change? A pointer variable, so we can just use actor, get actor name or label. That's the actor name, and that's what we're printing out. Now we can get rid of the old for loop. We no longer. Hello and welcome. In this lecture we're going to be seeing how we can add a tag to our gargoyle actor that makes it be the only actor acceptable to our secret door. Let's dive in and see how this actor tagging system works. Now, we don't want our trigger to be responding to every single case where we get an overlap. No, we want it to be responding very specifically only to one actor, the gargoyle. So how do we go about configuring this trigger so that the gargoyle is the only thing it responds to? Well, fortunately, there is a mechanism for tagging certain actors with certain strings to say that it has a specific property. So if you go and select the gargoyle actor and scroll down in the details pane, you're going to find, and in fact you can probably just search for it, you can search for tags, and particularly we're looking not for component tags but actor tags. You can see that there is an array element. Now we understand what arrays are. So you can have multiple tags. It's an array of strings. So the first thing in this array is you can add it with the add button, you can delete elements from it with the delete button, and then you can add in a string. So for example, we might want to put in a string that says it's going to unlock door 1. So we'll put in a string that says unlock 1, for example. And then what we want to do is check whether that string matches unlock 1 over in our trigger component CPP. So what we can do here is we can query the actor when we're going over the overlapping actors in our for loop, and we can check whether it has a particular actor tag. It's very easy to do. There is a function for it. So we do actor, arrow, actor has tag. And then you just have to pass in the name, the F name of the tag, which you can actually just use a string to put this in. So what we can do is we can put in unlock 1, like so, and we can put a semicolon at the end of the line, and we can wrap this in an if statement. So it's saying if the actor has tag unlock 1, then let's print out a log message, which is going to basically be that log message saying that we're overlapping. We can say actually unlocking instead, so that it's clear that there's a difference. And otherwise, if it doesn't find anything to unlock it, it's not going to print anything out. And let's remove the use of actor name so that all the log message says is that we are unlocking. Now let's recompile. And once that's done, let's open up our output log and dock it to the layout so that we can see the results. Let's go and start near our gargoyle, hit play, pick up the gargoyle, take it to the alcove. I just want to show you that if I step in, there is no log message. There's a log message coming from the BP player. We could remove that log, but there's nothing coming from our trigger. Now let's take the gargoyle and stick it in the alcove. And there you go. It can see that it is unlocking because of the tag that we have applied. So I'd like to challenge you to make the tag that we've got there configurable. At the moment, we've just hard-coded it into our code. So you're going to create a new editable U property. That's type should be an F name so that it matches what the actor tag is expecting. And you're going to replace your fixed string with this in the code and configure it in the level instead, which is the right place, so that we can reuse this trigger in multiple places. Pause the video and have a go. Okay, welcome back. So we're going to go over to the header file for our trigger components. We're going to go into the bottom and create a new private section and put a U property, edit anywhere, and it's going to be of type F name, not a pointer to an F name, an actual F name, which we're going to call the, I didn't tell you what to call it, but hopefully you tried to think up a good name. I'm going to call this the acceptable actor tag. Give it no default at the moment, and go over into our trigger. But hopefully you tried to think up a moment. I'm going to go and find search for tag, so acceptable. shows up straight away. And we're going to put unlock 1 to make sure it matches the gargoyle exactly. The string has to match perfectly. And that should have exactly the same result. Do go ahead and test it for yourself. Seen how to do that reasonably configurably and flexibly. Hello and welcome. In this lecture we're going to be making our trigger component print relocking when it has got an empty space, and when we put the gargoyle in it will unlock, and if I take it out again it'll relock again. And the way we're going to do this is by pulling out our functionality for finding whether we have an acceptable actor into its own separate function, and we're going to learn about early returns within for loops to do that. Let's dive in. So this chunk of code that we've got in tick component is already starting to feel like a function to me. Essentially it's a function that gets hold of the acceptable actor if we've got one. So we can go ahead to our trigger component.h and under the private section create such a function. Now what should its return type be? Well, I think it should be an A actor pointer, which can always be a null pointer if there is no acceptable actor. So we can then call this get acceptable actor, empty parentheses, we don't need to give it anything, and because it doesn't change our function we can make it const. Let's go ahead and implement this over in the CPP file. We're going to unindent it, give it a uTrigger component : and replace its semicolon with braces. And then the code we want is basically the contents of tick component, except what we don't want to be doing is just logging that we've unlocked our actor here. What we want to, and then the code uTrigger, go ahead and implement this over in the CPP file. We're going to undent it, give it a uTrigger component : except what we don't want to be doing is just logging that we've unlocked our actor here. What we want to do is, in the case where we've found this actor, we want to essentially be returning it. So there's a couple of ways we could do this. We could say at the start of our function that there is an A actor pointer, which is going to be the return actor, and by default we set this to null pointer. So there is no actor that we're going to return, but when we go through our for loop and we eventually find an actor that has the acceptable tag, then we can say, hey, the return actor should actually point to the actor pointer that we found here in our array. And then at the end of the for loop, after the for loop's finished, we've been through all the actors, we can go ahead and return the return. Actor variable, because that is the right type. That's okay, but it requires us to create a variable, and also it requires us to run through the entire for loop even if we've already found an acceptable actor. So a better way of doing this is using an early return, and we've seen this sort of thing before in our grabber CPP, where we've done this if the physics handles equals a null pointer. Then we return, and the rest of the tick component doesn't need to run. We can use the same kind of efficiency within for loops too. So what I'm going to do is, if we've found the acceptable actor, we're just going to do a return actor. We're literally returning the pointer that we'd just found in this for loop, and the rest of the for loop doesn't have to run. However, if we drop through to the end of the for loop and we have not found anything, we've not returned anything, the return would stop the for loop, leave the function. But if we get to the end, we need to return something by default. This is where we can just return null pointer. So this is the default value. It means we've gone through the entire for loop. We've seen that there is no acceptable actor. None of the actors that we're overlapping are with the correct tag, so we return null pointer. So now that means I've got this redundant return actor variable which I can go ahead and get rid of. And this reads really quite cleanly. We're going through, we're getting the overlapping actors, we are doing a for loop over them. If each actor, we test it, has it got the tag, the acceptable tag? If it does, we stop right there, we return that one. If none of them have it, we return a null pointer. So I'd like to challenge you to log if we find the actor. So call our function in your tick component, check if the pointer is null, and log in both cases, both whether we have an actor or if we don't, using an if and an else. statement. Pause the video and have a go. Okay, welcome back. So let's go over to our tick components. What we're going to do is we're going to create a variable A actor pointer, which is going to be the actor, which is equal to get acceptable actor. Then we're going to do if actor not equal to null pointer. Then in the body of this, we're going to do a ulog unlocking. And then in the else, another ulog, this time relocking, because that's the behavior I want our trigger component and mover together to have, is that if you've got the gargoyle in there, it's going to unlock, it's going to be using the mover, and it's going to be relocking if we basically uncheck the checkbox on mover, if we remove the gargoyle. So let's compile that. So let's go ahead and hit play. You can see it's relocking because we don't have a gargoyle in there. Pick up the gargoyle and bring him over. And there you go, it's now unlocking. Take it out, and it's relocking. Unlocking, relocking. Perfect. If I step inside, nothing happens, it's just relocking. So we've got successfully been able to find out whether we've got something in our trigger component or not. Now we just need to make it do something, and that's going to be the subject of the next lecture. I'll see you then. Hello and welcome. In this lecture we are going to be setting up the link between the mover and the trigger using a technique called dependency injection, so that by the end of the lecture, if we stick the gargoyle in, then the door moves down, or at least partially does. Let's dive in and see how this works. In our grabber CPP, we've seen that there is a dependency, what we call a dependency, for the physics handle. This grabber cannot do its work unless you have a physics handle component somewhere around. Now, it just so happens that the trigger component is the same. The trigger component, in order to do its work properly, needs to have access to a mover component. However, it's a little bit trickier in this case because, sure, in the case of our secret door, the trigger and the moving object are within the same actor. So you could get an object by finding a component of type on the actor. But what if, and we will have this situation in my crypt, where I want my trigger to be on a different part of the room from the actor that is moving? Well, to allow for that kind of flexibility, we want it such that the trigger doesn't have to go and find its own dependencies. And there's actually a name for this kind of programming concept. It's called dependency injection. Basically, it's in the case where we've got something that says, I need another object, but I can't find it myself, or I don't want to find it myself. And it's often sensible to not leave it up to the object that's doing its own job, making it have another job of trying to get hold of an object. So the way we can do this is to create a mechanism for blueprints to tell the trigger component where to find a mover. And the way we're going to do this is by creating a blueprint callable function on our trigger component.h. So it's going to be public. I'm going to put it in the public section underneath the tick component. And it's going to be a U function so that it can be then in the parentheses blueprint callable. And there doesn't need to be much to this function. It's going to be void because it don't need it to return anything, but it's going to be set mover. So it's going to set a link to the mover, and in order for it to set a link to the mover, it needs to take in a pointer to a mover component. So that's going to be U mover star, and we can just call this the mover, like so. Put semicolon at the end of that line. And we need to store this somewhere. So we're going to create a new private variable. It's not going to be a U property, and it's just going to be a U mover pointer, which we're going to call mover as well, like so. And what we're going to do is implement this set mover over in the CPP. So that it sets this mover pointer, which by default is going to be null. And we do have to do one more thing. We have to include the header file for our mover. Now, in this case, because the header file is in the same folder as the trigger component, all we have to do is hash include quote mover.a. And that's going to make sure that the trigger component is aware of the mover type. So let's go over into our trigger component CPP, and I'm going to put this below our tick component that we're going to implement set mover. We're going to put the class uTrigger component before, unindent it, remove the semicolon and our braces, and essentially all we're going to have to do here, let's change the name. Just in the C++ file, it doesn't actually matter whether the name of the parameters matches between header and C++, so we can change it here and say that the new mover is what's coming into set mover. And so we can set our local variable, our class variable mover, equal to the new mover, like so. Now, it's actually pretty important that you don't skip this renaming step, because if the input parameter is the same name as one of the variables on the class, then Unreal by default will set that to be an error. It's called shadowing, and Unreal doesn't want you to do it. So you do need to make sure you have your parameter named differently to the variable. Now, because these new functions don't always show up with live coding changes, I'm going to close down the editor, recompile from Visual Studio Code, and then relaunch from the U project. Now let's go to the content drawer, open up our secret wall blueprint, and then from our begin play node in the event graph, let's pull off of here and search for set mover. Now notice there are two options here. One, it would be to set the component, which is also called mover, and one is a function on the trigger component. So we want to select the one that's the function on the trigger component. And then what we want to do is drag in our mover component as the other argument to this function, and that should do the trick. It's set the mover begin play. So now essentially what we want to happen is that our trigger component should be setting and unsetting the should move boolean in here. So that's going to be my challenge to you, to create some public functions in mover.h and mover.cpp. It should be set should move, and it should update that uProperty variable. In fact, you can make it not a uProperty anymore because we're going to be setting it through code now. And then you can put it in the public section. It needs to be public because we're going to try and access it from our trigger component. And you can call it on the mover pointer that we've got in the trigger component from its tick component. setting the appropriate boolean, whether we want it to unlock, hold public to the mover, and in order for it to and we need to store this somewhere over in the CPP so that it sets this mover pointer, which by default is going to be null, and what's coming into. So you do need to make sure to close down the editor. recompile from Visual Studio Code, and then relaunch from the U project. Now let's go to the content drawer, open up our secret wall blueprint, and then from our begin play node in the event graph, let's pull off of here and search for set mover. Now notice there are two options here. One, it would be to set the component, which is also called mover, and one is a function on the trigger. Essentially what we want to happen is that our trigger component should be setting and unsetting the should move boolean in here. So that's going to be my challenge to you, to create some public functions in mover.h and mover.cpp property. We're going to try and we want it just under tick component. Move like so, class, and say that should, because if you should move equals new, what could be happening to them. Whereas if you have a method there to do it for you, we always use arrow set should move, and in the case where we've got an acceptable actor, that should be true, we should move, semicolon at the end of the line. And in the else case, well, then we probably shouldn't. So we're going to do mover, arrow, set should move, and in parentheses we put false. Remove that extra R that I had on the end of my method, and let's recompile. Now in this case, because I've only added this function in C++ land and it's not blueprint callable, I don't think I need to actually restart the editor for this functionality to work. Close down our output log, go towards our gargoyle and start playing and pick him up. Let's go out of this cage and stick it in the alcove. And there you go, it's moving down, but it stops as soon as the gargoyle falls out, which is not ideal, because the gargoyle is not really held in place and the wall isn't fully down, and because it's simulating physics, it's going to get popped out of that alcove, isn't it? So what we need to do is make sure once we drop it into our trigger area, it gets fixed in there and just stays. So that's going to be the subject of the next lecture. I'll see you there. Hello and welcome. In this lecture we're going to be attaching our gargoyle statue and switching off physics simulation when we stick it into the door alcove. So there you go, it's gone down with the door and we're able to access the crypt beneath. Let's dive in and see how it's done. So in the case where we do have an actor inside our trigger components, the acceptable actor, we want that actor to stop simulating physics, get attached to our trigger component, and move with us. How can we go about doing this? Well, the functions we're going to need are the following. We're going to need the actor's function called attach to component. This allows us to take an actor and attach its root component to another component, which will mean that the actor then moves with the component that's been supplied. The other thing we need to do to stop it simulating physics is on the primitive component itself, there is a function called setSimulatePhysics. It takes in a boolean, so you can set it to false so that it stops and it basically will stop being detached. Well, we've got one piece of the puzzle. We already have hold of the actor, that is the acceptable actor. Now we need to get the root component of that actor and see whether it is a uprimitive component, because it's not a given that an actor has a uprimitive component at its root. It just has to have a scene component at its root. So the way we can do this is we can go to the actor pointer. Make sure we're doing this in the if statement where we know it's not a null pointer. Do arrow, get root component. And if we have a look at the return type for this, we can see that it is a uScene component. Now that's a parent to the uPrimitive component, but it doesn't mean that this type is actually a uPrimitive component. So what do we do in this case? Well, we have to find out whether we've got a uPrimitive component, and we can use a function called cast. Again, it's one of these functions that takes compile time parameters, so we use the angle brackets, and we can give it that we want to cast the pointer to a uPrimitive component, close the angle brackets, and then in the actual runtime parameters, the runtime arguments, we do parentheses, and we include this actor getRoot component. So what it's doing is it's going to check whether this uScene component is actually a uPrimitive component, and the output will be a pointer to that uPrimitive component, or it will be a null pointer if in fact we had a scene component that wasn't a primitive component. So let's store that component pointer. So it's going to be a uPrimitive component pointer, which we're just going to call the component. And then before we use this, we need to make sure we check whether it's null. So we're going to say if component not equal null pointer, then we can do something with that component pointer. So I'd like to challenge you to try this out for yourself, setting up the attachment. You're going to open the docs in the links, try and read it, make sense of what it is saying you can do. Use the actor to attach to the current component. You can get hold to a pointer of the current object using this keyword in C++. Then for the second argument to that function, you will need to use the F attachment transform rules, : keep world transform. You can have a look in the documentation to kind of see what that means if you. Want to, and then finally use the component that we've cast to disable physics, again using the documentations to see which function and what parameters arguments to put in. Pause video and have a go. Okay, welcome back. So first of all, I'm going to use the component to disable physics, so it's going to be components, arrow, set, simulate physics, false. Looks like I've got a semicolon missing at the end of my cast line, so let's put that in there as well. And then we're going to attach the actor. So it's going to be actor, arrow, attach to component. The component we're attaching it to is this. So let's have a look at this second parameter. We've got this F attach transform rules type, which is obviously a struct. And it basically tells us how we should handle the attachment. There's a couple of pre-built ones in here. We've got the keep relative transform, which would essentially move our object when we attach it. So we don't want that. What we want is a keep world transform. So we're going to use that. So it's F attachment transform rules, : keep world transform. Put a semicolon at the end of that line and recompile. So that's done. Let's hop into the editor. Go ahead and hit play. Grab our gargoyle and stick him into the alcove. And you can see he has gone down with the floor. And the floor's gone all the way through, allowing us access to our crypt. Fantastic stuff. So in this lecture, we've learned about